Well, you might be wondering, well, why are we bothering with radians? Why don't we just do everything with degrees? Well, there are many basic problem types that require that you work with radians. Now, strictly speaking, that's not required. There is a workaround, but the workaround is so cumbersome and so problematic that it becomes not tenable for basic work. And there are certain places in the calculus that, because of the structure that we're dealing with, radians are required. And so we're going to now work with a problem type called arc length, which is, for our purposes, we will simply say it requires that we work with radians. The arc length works like this. It relies upon a formula or a property that we generate from basic geometry. And it says this: if this is a circle of radius r, so the radius is r, and if I have an angle whose vertex is the center of the circle, an angle whose vertex is the center of the circle. Suppose I have, it can be any angle we want. There's my angle theta. Then the question is, if I were to take a measuring tape and lay it out on this curved circular arc, the question is, what is the length of that curved circular arc? And if and only if this we assume, if theta is measured in radians, if theta is measured in radians, then this relationship holds. This is r is this radius. Theta is the measure of the central angle. It's got to be when we say central angle, it means the vertex of the angle is the center. And then S, we use S for the arc length. When you get to Calc 1, you'll use S for arc length. When you get to Calc 3, you'll use S for arc length. S is the symbol everyone uses for arc length. So S is the arc length, R is the radius, theta is the central angle. We assume theta is in radians, then the following holds true: S is equal to R theta. S is equal to R theta if theta is measured in radians. Only if theta is measured in radians is that true. It doesn't matter how big the angle is. We could have used a much larger angle. We could have used that angle. So there's a central angle. Now the arc length is here. And so S is equal to R theta, where theta is measured in radians. Now using that, we can do all sorts of problems are now available to us. One of the basic problems you see at this level of study is the latitude problems. Now, okay, so assume this is the North Pole. Assume this is the equator. Right? This is the equator of the Earth. And this radius, we have the radius of the Earth. Our text does all these problems in kilometers or kilometers. And so the radius, if this is Earth, then we will use the radius to be 6,400 kilometers. It's an approximation. It's close enough for our purposes. And so we can find, we know the radius of the Earth is 6,400 kilometers or kilometers. Now, we understand that we have angle of latitude, right? As you go north from the equator's latitude is 0. But as you go north on the Earth, the angle of latitude. We're familiar with latitude because of the coordinates we get for hurricanes and tropical storms. And so the latitude. And so if a point on Earth has an angle of latitude, suppose the angle of latitude, let's say it's 38 degrees. What that means is this. What that means, if this is 38 degrees, what that means is, if you drew a line from that point on the Earth to the center and measured that angle theta, that angle would be 38 degrees. All right? Now here's what we're going to do. Call this point A and call this point B. We assume in all of this work, we assume that points A and B in all of these problems are on the same angle of longitude, which is to say they're on the same north-south line. All right? That point B is due north from A. So as A head north through the equator, you'll run over point B. A is due south from B. So they're on the same vertical angle, they're on the same latitude, but different longitude. So the question is, how far apart are they? What is the distance between them? And the way we answer the question is S is equal to R theta. All we need, so we're asked to find, right? This is S, right? We're asked to find the arc length. We're asked to find S. We know R. We're given theta. However, theta is given in degrees. So this is a two-step process. What would be wrong, in fact, I'll do this in a different color here. What would be wrong is to say S is equal to R, which is 6,400. That's fine so far. But then if you put in 38 degrees, this is wrong, because this formula requires theta must be in radians. So step 1, convert from degrees to radians. Step 2, plug and chug. The rest of this falls out very straightforwardly. There are a couple little quirks here and there to watch for, but this is essentially, this is very straightforward here. Step 1 is we convert this degrees into radians. So 180 goes to pi as 38 degrees is to, don't know yet. In fact, what I'm going to do is this. I'm going to call this my angle theta. When I do this work, my angle theta is going to be my radian angle. This angle I'm going to call alpha. It's the first letter of the Greek alphabet, alpha, beta, gamma. This is lowercase alpha in the Greek alphabet. So alpha is 38 degrees. Theta is, we're going to find it. So, cross multiply, set them equal, and solve. So here we go. So 180 theta is equal to 38 times pi. Divide both sides by 180. So this is 38 pi divided by 180. And let's go to the calculator. After you show me what you're doing, this way I know that you know what you're doing. Show this work neatly. Don't show it scattered all over hither and thither. Show it nice and neatly here. That way I can follow your logic. My next value is 38 times pi divide by 180. And my value is 0.66322. Now here's what I want you to do with this. This is not your final answer. We're not done yet. We're going to use this. I'm going to take this value and use S equals R theta. So this is step 1, step 2. Leave this number in your calculator. Leave it in your calculator. Don't round this now. If you round this, then use a rounded value here, you're going to accumulate round-off error. So what I want you to do is leave this number in your calculator. Don't clear your machine. Because now this is the value for theta. The rest of this is straightforward. We need to find S. R is given, 6,400, times the value of theta, 0.66322. Put the dots. That way I know that you are using the entire decimal string that is lost out in the calculator. And now all you need to do is do times. Take that answer times, take that answer times 6,400. And now my answer is 4,244.6407. And let's assume that we want 1 decimal. So we want to round this to 1 decimal place. Let's just write this as 4244.6. All right. So the distance between those 2 points on the Earth's surface is 4,244.6 kilometers. This doesn't take nearly so long if you don't need to explain it as you're doing it. It's straightforward. Take the given angle alpha, convert to radians theta, leave that number in your calculator, multiply by the 6,400, and you're out. It's straightforward. All right? Now, the points in question, one of the points in question is not required to be on the equator. We could find, as long as we're assuming the points are vertically north-south aligned, then we can find any 2 points that are north-south aligned anywhere on the Earth. So let's assume point A is 48 degrees north. What that means is north of the equator. And point B is, let's say that's 15 degrees north. We assume in all these problems, we assume they are north-south aligned, that they're on the same angle, same longitude. And we want to find the distance between north-south. Let's round to 1 decimal place. And we also assume that R is equal to 6,400 kilometers. All right. So a little sketch might help here a little bit just to make sure. So now we're not given one of the points is on the equator. Here we're given 2 points, neither of which lie on the equator. So let's just draw a little picture here to see what's going on. So here's the center of the Earth. There's the North Pole. But here's the equator. We don't want that line. We want 15 degrees north of that. So this angle here, there's the equator. There's 15 degrees. This is point B at 15 degrees. Point A is up here. And this angle is 48 degrees. We want, our angle is between A and B. We want that angle. All right? So if this is 15 and this larger is 48, then this piece in between is the 48, take away the 15 we don't want. So step 1 is to find the angle in question. And I'm going to assume you can handle that. Just draw a little arc. Doesn't have to be perfectly circular. Just draw a little arc, make the equator, put the 2 points, mark the angles. This is the angle we want between A and B. So our angle alpha is the difference from 48 to 15. So that would be 33 degrees. So our angle alpha is 33 degrees. And so now we're back to the same 2-step process. Convert from degrees to radians, and then use that value in the S equals R theta formula. So this is very straightforward. R is given to be 6,400. So see if you can work this the rest of the way out. Pause the video. And then when you're finished up, I'll see if I can match the work that you've done. All right, let's see if I can do this right as well. Step 1 is to convert this to radians. So 180 is to 33 as pi is to theta that we're looking for. Cross multiply. Now, textbooks have this. Some instructors may say this. A tutor might tell you this. Some online advice might say this. They'll give you a formula for computing how to convert. If you want to do that, that's wonderful. That's great. You'll do fine by it. I just set this up every time. That way I'm not taking any chances. Just set this up every time. It doesn't matter if you're given degrees and want to find radians, given radians and want to find degrees. Doesn't matter what you're given. Doesn't matter what you're looking for. This will always work. Set up the proportion, cross multiply, solve for the one you want. So this is 33 pi over 180. And find the value, but leave the decimal string in your calculator. So I need 33 times pi, where's my pi's right there, and then divide that by 180. And my value is 0.575958, 0.57595, yada, yada, yada. And that's the number I'm going to use in S is equal to R theta. All of this work should be very neatly done. So my neatness is questionable, but you're a student, of course. And so you make sure you show this work in a nice, neat, don't just throw bits here and bits there and stuff over there. This is the computation to convert to radians. And now this is the computation to find the value for S. So S is equal to R is 6,400. Theta is the 57595. Indicating that it goes on. This has not been rounded. And then take that number in my calculator times. I want my answer times, what is it, 6,400? And I get 3686. Point, I'm going to round to one decimal, so I'm going to say that's 0.1. And this is, to keep the physics people happy, this is in kilometers. So I should put my units on there to keep the physics people from jumping down my throat. All right? All right, let's work one more of these. In this case, both points were north of the equator. The same thing would happen if both points were south of the equator. You'd subtract the greater minus the lesser and get the difference between them. Let's play one more. What if one point is north of the equator and one point is south of the equator? So we're given, again, R is our same 6,400 kilometers. We're given point A corresponds to latitude 64 degrees north. Point B corresponds to latitude, what do I have here? 27 degrees south of the equator. A picture might help to make sure we know what's going on here. So let's make a little representation here. This is my Earth. The Earth is actually much bigger than that. You know this. This is the North Pole. Here's the equator. A is 64 degrees north, so 64 degrees north. It doesn't matter if this is accurate, just make a reasonable picture here. There's point A, and we know this is 64 degrees. B is 27 degrees south of the equator. So now we're down here. This is B. And this is 27 degrees. And we want to find the distance between them, A and B, which means this is the angle that we want, right? This is our angle theta. And so in this case, you don't subtract the two. Is it clear? You add the two. So to find the angle, first off, we have to compute alpha and then take alpha, convert it to theta. But this is the angle we want. So in this case, alpha, if one's north and one's south, we add. Technically, you're subtracting the negative, but you add. And if they're both on the same side of the equator, then you would subtract the two. In this case, this is 64, is my alpha. Alpha is 64 plus 27. And that's, what's that, 91, is that right? So that's 91 degrees, but that needs to get converted. And again, why don't you go ahead and pause now and see if you can finish this out by yourself. And then I'll come up and sweep up any stragglers that might have missed the bus here later on. Okay, so let's convert 91 degrees. We have 180 is to 91, as pi is to theta, which I don't know yet. And so cross multiply, 180 theta is equal to 91 pi. And so theta is 91 pi over 180. And I have that worked out to be 1.5882. Yada, yada, yada. Again, leave that in your calculator. Leave that in your machine. Let me double check that to make sure I didn't screw this up. I got to be careful here. So let's clear that out. Let's go 91 times pi. And divide that by 180. And there's my 1.5882, blah, 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 blah. That now goes into S is equal to r theta. R is 6,400, hasn't changed. Theta is the same number we just found, 1.5882. And take that times 6,400. And my number is 10,164. Point, and again, we want 1 decimal. I didn't state that. 1 decimal rounding. I will always give that to you. I didn't hear, but I will always give you the decimals that you want. And so it's 0.79, 7, yada, yada. So we will use 10,164.8 kilometers, if you like. And there we go. So that's one standard kind of problem we'll work with. This requires radian measure. If you tried to work this problem with 91 degrees instead of the radian measure, if you use 91 degrees here, you would get 91 times 64,000, which is 582,000 kilometers. That's more than the distance from the Earth to the Moon. So that's a rather long trip. So you must convert these to radians before you do this computation, S equals r theta.